is section 0.4.2, direct. First, we talk about direct variation. As one quantity goes up, the other quantity goes up. As one quantity goes down, the other quantity goes down. Therefore, we say the quantities vary directly because they're doing the same thing. Here's an example of solving a problem using direct variation. The amount of garbage created in a geographic area varies directly as the area of population. Allegheny County, Pennsylvania has a population of 1.3 million and creates 20 garbage each week. Find the weekly garbage in New York City with a population of 7.3 million. So now that we've read the problem and we understand what we're trying to solve for, proportion. In this, we know that Allegheny County, Pennsylvania has a population of 1.3 million and creates 26 million pounds of garbage. So we can set up a proportion 1.3 over 26, knowing that these numbers are in millions. Next, we're going to look at New York City. We know their population, but we don't know how much garbage they have. So when we set up our proportion, we put the population on top for Allegheny County, so we're going to put the population on top for New York City. On the bottom of the Allegheny County ratio was the amount of garbage, so on the bottom of the New York City ratio will be the amount of garbage, which that's what we're trying to find. Now we're ready to solve the proportion. We know we solve by cross multiplication. 26 times 7.3 is 189.8. And now to solve for x, we're going to divide both sides by 1.3. And we're going to get 146. Remembering that our numbers are all in millions, so this is 146 million pounds of garbage in New York City each week. That's a lot of garbage. So looking back at our setup of the proportion for this problem, since it was a direct variation problem, you'll notice that we put corresponding values in the same ratio. So in this case, the left ratio was for Allegheny County, and the right ratio was for New York City. On top, we had populations, as we talked about before, and on bottom, we had the pounds of garbage. And finally, by looking at this problem, you'll see that it was indeed direct variation. First of all, the problem itself told us that right here. But you'll see that whenever the population in New York City went up, the amount of garbage went up as well. All right, next we're going to talk about inverse variation. As one quantity goes up, the other quantity goes down. Or as one quantity goes down, the other quantity goes up. In an inverse variation problem, corresponding values are placed in opposite ratios. This is very important, and this is actually different than what we saw in the last problem that used direct variation. So it'll be very important to remember that in an inverse variation problem, corresponding values are placed in opposite ratios. Let's take a look at an example. The distance from Atlanta, Georgia to Orlando, Florida is 450 miles. If you average 45 miles per hour, the time for the drive is 10 hours. Find how long the drive will take if you average 75 miles per hour. All right, so the first thing you need to decide when reading this problem is whether it is direct variation or inverse variation. We can tell in this problem that it's inverse variation because, of course, the faster you go, the quicker you'll get there. So as your speed goes up, the time it takes to get to your destination goes down. That makes it an inverse variation. So now it's time to set up a proportion. Well, we know that in our trip from Atlanta to Orlando, It's 450 miles, so if we're averaging 45 miles per hour, 45 miles per hour, it's going to take us 10 hours to get there. So 45 miles per hour and 10 hours correspond to each other. But since this is an inverse variation problem, we do not put these numbers in the same ratio. We actually put them opposite each other, as you can see I've done here. So now it says find how long the drive will take if you average 75 miles per hour. Well, since we put our 45 on top, that's our speed, we're going to put speed 75 miles per hour on top again over here. So if we're going 75 miles per hour, how long is it going to take? Again, we put corresponding values in opposite ratios when it's an inverse variation problem. So here's the setup of our proportion. Now we can cross multiply and solve. So x times 75 is 75x. 45 times 10 is 450. Divide both sides by 75. In this case, we get 6 hours. And we see once again that as our speed went up to 75 miles per hour, the time it took to get it to our destination went down to 6 hours. This has been section 6.4.2, direct and inverse variation.